SwayamPrabha. Digital India. Educated India.
Okay, so welcome back. This is the fourth video for week 7, and we are looking at the alternatives to plastic, the greener alternatives, bio-based alternatives. So this is in this video. In the previous video, we were focused mostly on some of these plastic, like a greener product. They were also bio-based. So we'll continue. We can say that we are continuing the similar discussion and looking at the other plastic products. What are the other alternatives out there? And then I think in the next video after this, we will be looking at how to even quantify, because there are a lot of greenwashing also happening, where people are claiming something green, but they are not really green. So how to quantify if something is green or not, we'll talk about that as well. So in terms of the alternatives, cornstarch and sorghum, they are also being used quite a bit in making this plastic alternatives. So maize, better known as corn, is an which it's produced is annual produce, which gets produced in many parts of the world, including India. It's a staple food, like your cornflakes and many things are made out of corn. And so again, the corn or maize, there is a photosynthesis like any other plant. So it absorbs CO2 and water into glucose and oxygen. So the non-required sugar is stored in the form of starch. This corn starch is relevant because it forms the raw material for the production of bioplastic. So that's, you can make with the corn starch, you can make bioplastic. So there is a EcoFlow loose fill is made from cornstarch and can be used the same way as a regular polystyrene loose fill. But this eco version, which can also be made from sorghum, which is crop similar to maize, is biodegradable, odor free, and maybe best of all is static free. So it's easier. So these products are biodegradable. They don't have any kind of a smell as well, and maybe best of all, they are also static free. So there are these are the production steps for bioplastic products from the corn starch. The corn starch is fermented into lactic acid. So if you can look at here, they are forming lactic acid, and by the aid of lactobacillus. So and this lactic acid then transformed into a long chain carbon polymers, which is called polylactic acid. In the short form, you hear a lot PLA. So PLA based plastic, and that's the polylactic acid based plastic, and this is molded into so you made a polymerization. So this then molded into small plastic pellets, and these pellets are then used to produce many different objects. So similarly, if you remember from the first video of this week, or I think it was in the first video, maybe in the second. So there again, when we are trying to do those mechanical recycling, it was doing the same thing. We are making those plastic pellets. So rather than using those oil based plastic resins, here we are using bio-based polymers. So that's the difference, and since these are bio-based polymers, they are mostly biodegradable. So and they can biodegrade in traditional like waste management system, whether it's a composting, anaerobic digestion. So then they are used. So they are small plastic pellets, which is used to produce many different objects. So in this case, in plastic pellets are used to produce bioplastic foil. Subsequently, the foil is used to produce PLA cups and bowls, and run through different machines, shaped into objects different with the form of die cutters, impact of heat and all that. So then PLA cups and balls are ready for use. So you can use and that's for the green box, that particular product brand, which they use that. There are other brands out there using PLA as well. So you will see variety of products coming out from polylactic acid, which is earlier whenever we used to call bioplastic, this polylactic acid was the one which was getting the most like a name, although it became like a synonyms for bioplastic. So, PLA based plastic was called bioplastic, and but then since other sources came in, so we are being a bit more when we say PLA based plastic, it is part of bioplastic, of course, it is a significant portion of bioplastic, but there are other types of bioplastics as well. So, when you look at the sustainability of in terms of the bioplastic stuff, it is a no waste from non-renewable sources. So, it is mostly renewable sources which we have. So, it is a here the bioplastic is a renewable herbal source, which is corn, and does not contribute to the waste of non-renewable sources such as petroleum. Corn is used for the starch production, which is not intended for human consumption. So, part of the corn which is not used in human consumption is used for that, otherwise that is also a problem. See, when this biofuel industry came in last decade, one of the problem that we were facing was because the food prices went up. The reason the food prices went up is many of these corn and other stuff which were supposed to be on our plates in different forms, they were being diverted to the bio oil production, and when because they were making more money. So, when they go for the bio oil production, so amount of corn goes down in the market, food prices goes up, as you know, demand and supply, basic economics. So, since the supply demand is always more population, more people, affordability going up, people are becoming little, I would say in general, if you look at I would say the salary level of people have gone up, although there is, if we talk to social scientists, there are a lot of issues of disparity in the country. There are poorers are becoming poorer, not only in country or also abroad, like globally. Poorers are becoming poorer, richer are becoming richer, but that those are true to some extent, but at the same time in general, if you look at, there is a upward trend of the society, the affordability for different stuff has really gone up if you look at the way the market is right now. So, in that case, if you have more demand for food and with the higher population and higher affordability, but you take the corn away from the food market and put it for your like a bio oil or biodiesel, the food prices has to go up, and that is what happened. So, food prices started going up, and then the people realized that this is not the way to go. We can use bio based waste material. So, we can use the bio waste, biodegradable waste or organic waste, any food agricultural waste, and use that as a source for making these alternative products. But anything which is grown for the sake of consumption, which we are used to consuming, especially the staple food like maize or whether we this should not go into alternative products, because then it becomes a problem for the food industry. So, it is not intended for human consumption. It is only 0.05% of the global starch production is used for the manufacturing of bioplastic. Therefore, the cultivation has no impact on the food supply on human and animals. So, that is so special characteristics for this is a high stability, free from BPA, bisphenol A, if you remember that from last week videos. It consists of 100% renewable, like 100% raw, 100% natural raw material. It is biodegradable as per the European Union. It meets that criteria, thermoplasticity, and therefore molded into any object. So, you can put it in whatever shape and size you want, and that becomes like you can put in you can make different types of products out of that. So, then another things are coming up. There is one company which has come up with a eatable 6-pack ring. So, this is you can eat that. So, brewery has created edible 6-pack rings that are safe for animals to eat. This is saltwater brewery. This is a 6-pack holder. So, you have 6 packs together. So, they can be used for different applications, for different, these cans are used for soda, cans are being used for beer, like even for beer and other stuff, cans are, and there are a variety of soda, even the lemon, this is Nestea, different types of drinks, these cans are used, and so 6 cans together usually are put into a 6-pack ring, and that becomes kind of, you can buy 6 together, and this is how you see them in a superstore. So, when you put usually these used to be made out of plastic, and of course, these are your metal stuff, aluminum most of the time, but these are your plastic material which used to create problem in the ocean, and these plastics will break down, and then it becomes a like a microplastics, and then fish used to eat that. So, if it's a eatable, if it's a biodegradable and eatable, so it's easily coming from barley and wheat. That's what it is being used, and it's from the byproduct, from the waste product of coming from brewery industry. So, these are left over from the brewery process. So, so even in this case, if this ring ends, rather if not, it's not a plastic ring, but it is the like a biodegradable ring, so or eatable ring. So, when it goes to ocean, even if when it ends up in the ocean, it's eatable. So, animals can eat it, and it will degrade. It will not take the time that plastic takes to really plastic stays in the marine environment for a very long time. So, so the design is just as strong as the plastic packaging. So, that is also very important. It should do the function. It's a bit more expensive to produce. So, that's what I was trying to tell you in the last video, that these kind of industries need some sort of support in the beginning. Just to get into the market, start selling a good numbers of their products, and mature a little bit, so that they become price competitive. Any product, when it comes for the first time, it's costly, but once it's volume starts, and then the prices goes down. So, that's so that is it's needed for that. Moreover, however, it hopes customer will be willing to pay a bit more in order to help the environment. So, that's what the company is hoping. So, it usually, if it's not too much, there is a market out there now. People want to buy green products. There is some sort of I would say section of population is already looking at, they are ready to pay, say 10%, 15% more on any product to buy something greener, but it has to be greener first of all, and that there should be a checks and balance on that. It should not be greenwashing. Greenwashing is when the companies claim something is green, but when you do the real investigation, you found that actually it's not green. So, that should not happen, and at the same time it should be it should not be too costly, because every family's budget is also limited. So, if it's too costly, then it becomes difficult. Like people can spend a little bit extra, maybe 10 to 15% extra maximum to buy something greener. I am talking about in general. There will be some crazy people who can pay maybe twice the money to get it. I should not call them crazy, but they somehow environmental friendly people who can do that. But in general, middle class, lower middle class, upper middle class, their budgets are always limited. So, it's so that's, but if it even but these products are useful, and when they end up in the ocean, it starts what has been found, that in a matter of hours it starts breaking down, which also address the issue of animals getting stuck in them. So, animals we saw that some of the videos last week, where that animals were they were like the plastic rings, and even in one of those if I remember correct, that straw got into the nostrils of one of the turtle. Then the turtle has a lot of wires, like plastic wires all around him, even if its neck was covered with those plastic wire, and we saw all that, and it's really sad because we are destroying their habitat with all these waste getting in there. But so these kind of product, even if it ends up in ocean, of course, the goal should be that none of these plastics should end up in ocean. If we have a proper plastic waste management program, it will not. And that's again we are talking about lots of plastic products, alternatives to plastic products, but the title of the course is plastic waste management, and we should not lose that focus that it is plastic is not a problem, it is the plastic waste which is a problem. So, once we dispose that plastic, whether it is a regular plastic, the petroleum based plastic, or even the plastic that we are proposing, like all these examples that you are seeing in this video in this particular week and different videos, they also needs a proper plastic waste management. Yes, the managing those plastic will be slightly easier now, because they are degradable to most part. So, I can use it in my composter, I can use it in my anaerobic digestion. When I say like as a city level, as a ULB level, we can manage it, but these will also produce, if biodegradable means they will produce CO2, they will produce methane, and the CO2 and methane, if not captured, or if it is not if we just leave it to go to the atmosphere, I do not know whether we are really solving the like we are only solving part of the problem, because it's more like a problem sifting. Earlier it was that is a severe problem, that plastic is, especially that single use thin plastics getting in a smaller pieces getting into the ocean becomes an issue, but replacing it with this biodegradable plastic and then just do nothing into this biodegradable plastic waste management, that also is a problem by itself. So, it is we are doing only part of the solution, not the complete solution. So, plastic waste management, having a proper plastic waste management, which will be the part of your ULB solid waste management, because plastic waste essentially most of the plastic waste you will see is coming from the municipal waste. So, that needs a lot of focus. That is why this waste management is right now in a country like India, with all this Swachh Bharat mission program, smart cities program, we need to really focus on a good workable waste management infrastructure, and that is what some places it is happening. So, we will see how it gets done in many parts of the country. There is some work already kind of started, and it is going on. So, coming back to this edible 6-pack ring, which is can be eaten up, even if it goes to ocean, it is not that bad. So, let us in this next slide, we have a small video which is trying to go over the detail of these 6 packs. So, let us look at that, and it has a subtitle. There is no we have not put any audio here. So, as you can see, they are made from leftover from the bear, that whatever is the leftover. So, even if they can be eaten, or they will just decompose. So, even if it ends up in the ocean, the animals will not be entangled in them, and because it is easier, it will decompose quite fast. Similarly, there are other bottles out there. These water bottles that decompose by itself. This by one of the Johnson, a product design student, he has come up with that, and when he looked at all these plastic issues, as you can see on that video, that there are several plastic going into the ocean, some of them going into the ocean, but going in a waste stream. So, more than billions plastic bottles are used in the world, and it takes 1,000 years for all those. So, this biodegradable bottle is made from red algae, and then it is made from 100% natural material, and you can use that bottle, and after you drink that water, it starts. After you drink that water, it starts melting by itself. So, and then you don't have to really worry about that water bottle. So, it decomposes and gets used up in by itself, like it will become part of your say if you put it in a composter, it will compost there, it will put in anaerobic digestion, it will get anaerobic digested. If you do not use it anywhere, it will just decompose in the atmosphere too. So, these are some of the alternatives which is being used, and it is made from, so many of these are naturally made stuff, and so they are coming into the market. They are picking up, but still there are limitations to these products in terms of price and some other aspect in terms of strength. As I said earlier as well, many of these bioplastics still are not 100% bioplastic. They have some traditional plastic blending just to give required strength. So, those things are being worked into in terms of research right now. So, that was on bio-based plastics. Some other examples, there are some paper based products are also coming up, which is taking the space of what the single use plastic products had. And one of them was high function packaging material, which is the metallized paper. This is silver board metallized paper. It is a spatial paper. It has a metallic layer vacuum deposited on the surface for decorative effect, and this offers a solution to achieve distinctive metallic finish on packaging with only fraction of the aluminum content of traditional foil. So, and the material again remains compostable, same as paper. So, it's can use for labels and packaging of beverage, food, and they are and consumer products by approximately 300 companies in 80 countries are looking at this product. And earlier it was many of these plastic based product was being used. So, it is replacing those plastic based product by this paper based product, and which is environmentally friendly, more compostable and all that. So, that is another area. So, in terms of these metallized paper, what they are, this is paper is pre-coated with lacquers that are applied on to smooth out the surface of the paper, to act as a barrier between the paper and the metallized layer, and to improve adhesion of the vaporized metal. Then you have a holographic effect. The paper is then micro embossed using a proprietary patent process to create the visual effect desired. Pre-coated paper is then metallized directly. All metallized paper then top coated and re-moisturized is a final process. The coating protects the aluminum foil from damage and serve as a print receptive printer, and so they can print different like logos and other stuff. For linen brushed or pinhole embossed, the metallic paper is micro embossed for the desired texture. So, there are this is kind of the basic of the production process. We do not, as a waste management person, we do not have to worry too much about the production process. What we worry more about what is the waste coming out of it. Production, we can leave it to our chemical engineering friends. But in terms of what is its key feature, where it can be used, and then when it comes to the environment, what could it will potentially problem may arise from that, or what can we do the resource recovery, what kind of resource recovery we can do. So, here in terms of key features of this metallized paper, its excellent printability, it prints really well. It works with all printing technique like offset, rotograph, UV, flexography, and some digital, and also different types of ink, solvent based, water based, UV curable. It facilitates cutting, it resists curling, labeling and recycling, peels off with washing to ensure ease of handling by the customer. So, when you are peeling, it can easily be peeled off during the recycling. That is really good. You do not need that glue, I think over there that is typically there with other labeled material. Is stable quality, high productivity, low cost, higher biodegradability of paper over the film, because we used to use a lot of plastic film. So, if you can replace those plastic film by this, it becomes easier, and they already are being used in 80 countries, but more than 300 companies. So, this is this market is this product is already there, which is replacing the film plastic by this metallized paper, which is environmentally friendly than others. So, you see here some of the applications of the metallized paper. So, these are different labels from different companies, different products. So, these are all these labels are all metallized paper. So, this is from this silver board is the company name, and you see that different applications here for some containers, some box, even for different types of boxes. You can put as a label for drinks, even part of the for the tissue paper container, tissue paper boxes, and different applications. So, you can use these applications are used for metallized paper, which is already being used for different product. And there are some other there is say wood pulp cellophane is also cellophane, which again for is like a packaging different product. So, there are which has a lot of plastic, and it was plastic based. Now, when we say plastic based, means the traditional plastic based. Now, there is another variety of it is coming out in terms of using from wood pulp. So, the company here, the Nature Flex, is the sustainable younger brother of cellophane. So, cellophane is what we have used, which is made from food certified wood pulp, and certified biodegradable. It comes as uncoated. You can use it for chocolate, confectionery as well as household items, semi permeable, which can be used for fresh produce and dairy, and barrier you can for bakery, snacks, coffee, tea, chocolate. So, you can have semi permeable as well as like a non permeable coffee, tea, chocolate, confectionery. As you can see the pictures here, all different types of packaging can be done using these material. So, this is again it is coming from wood pulp rather than it is a plastic based. So, these are the alternatives which is environmentally more greener alternatives, and when we are claiming, we are suggesting many things are environmentally greener, but we will also talk about it's very in this week itself, like how to quantify that, how to really say that something is green, because that is important, because otherwise how we will know how much green it is, because whenever you come up with a newer product or newer process, and then you say that this is better than my older process or older product, we need to know how much better, how to quantify that. So, that those kind of discussion we will do in maybe in the next video. So, there are some scientists have made grocery bags out of shrimp shells. So, that is another from the shrimp shell. There is in researchers from Nottingham and Nile University, they have synthesized a biopolymer nanocomposite material which can make production of affordable biodegradable plastic. So, they have taken they have developed the polymer, but dissolving the chitosan flax derived from the shrimp shell in a solution before a plastic film is deposited, uses a traditional polymer processing technique. It is a degradable, antimicrobial, antibacterial, biocompatible property. So, it makes it makes it useful, and the researcher says that use of a degradable polymer made of pond cells for carrier bags would lead to lower carbon emissions and reduce food and packaging waste accumulating in the street or legal dump site. So, that is so you are basically, you can, many times we hear the term, you are trying to kill two birds with one stone. So, here if you do that, you are also reducing the food waste coming from this particular industry or this particular stream, and that is a win-win, because a newer product is being made, and at the same time we do not have to manage it as the waste in a dump site or in a landfill. So, these are some of these examples of shopping bags and other containers made from shrimp shells. So, as you can see, different types of containers, cups, shopping bags, they are all coming from shrimp shells. So, which is already in the market. So, once this bioplastics are used up, what are the different ways which it comes to the environment, because we are saying traditional plastic is bad. So, let us replace with bioplastic, greener plastic, whatever we call it, environmental friendly plastic. This environmental friendly plastic also needs their disposal after its use. So, that is a very important part of it. So, there are different ways it can be disposed. It can go to a landfill, it can go to littering, domestic composting, industrial composting, incineration, biogas, breakdown in the ground itself. It can go into our body too. You can go for recycling, different types of recycling. So, there are variety of ways it can go into the environment. So, we'll spend some more time on this. We'll start from this particular slide in the next video. We'll explain each one of those a little bit in detail, and then we'll also look at how to quantify the environmental impact, overall environmental impact, when we move from one type of plastic to another type of plastic. So, the whole concept of life cycle analysis, that cradle to grave or cradle to cradle concept, that we'll discuss, and that will kind of lead us nicely to the next week, which is on circular economy for plastics. So, again I hope that you are enjoying the course so far. This is week 7, fourth video is this is we kind of end of the fourth video. There is one more video in this week which will have it right after this, and again if you have any questions, put it on the discussion forum. We will be very happy to answer any question that you have. And at the same time, if you find some new information, if you find some interesting information regarding plastic waste management, plastics in general, which you think is relevant for this course, put it in the discussion forum, which will help us, enrich us, all of us, including our team, the instruction team, Because as I said several times in this course so far, there is no a standard textbook on plastic waste management yet. So, what information presented here is essentially collation from different sources. So, that is why we have given you a lot of reading materials as well every week. So, look at that and do your quiz carefully, nicely, and all the best, and see you again in the next video.